So we have some common types of graphs that we are going to look at. The graphs, some common graphs that we need to look at, showing the variation of these quantities with time. One graph that we are going to look at is a graph we call the distance time graph. The distance time graph. Then we'll also look at displacement time graph. The displacement time graph. Displacement time graph. And also we also have the velocity time graph. The velocity time graph. So these are the graphs that we are going to look at: the distance time graph, the displacement time graph, and also the velocity time graph. Because we have seen that we can represent the variation with time graphically. So we are going to base our discussion for this lesson in the distance time graph. The distance time graph. Distance time graph. Distance time graphs. We can talk of the graphs because we are going to consider various motions. Distance time graphs. We are talking of the motion graphs. So we are going to represent various motions of bodies using the distance time graphs. Now, when you see the distance time graph, it simply refers that the distance, whenever we are plotting this graph, the distance will appear on the y-axis. So we have the distance here, the distance in the SI unit, which is meters. Then we have the time on the x-axis in seconds. So a distance time graph. The same case will apply to the others. The displacement time graph, displacement will be on the y-axis, then the time on the x-axis. Velocity on the y-axis and time on the x-axis. So I want us to start with a body, a stationary body. The distance time graph for a stationary body. A stationary body. A stationary body. When we talk of stationary, the word stationary means that it is not in motion. A body that is not moving. If a body is not moving, for example, if you place a body on a level, for example, on a table, and the body is not in motion, we say that the body is stationary. And therefore, for that body, it will cover zero distance. The distance covered will be zero. Even if the time may be changing with a certain time, maybe time changing from 1 second to 10 seconds, the distance is not changing. And therefore, we are going to have the distance time graph for that body. A distance time graph. Whenever you are plotting a graph, ensure you start with the axis. That is, we have the y-axis. Then we also have the x-axis, y and the x-axis. In our case, on the y-axis, we have the distance. And on the x-axis, we have the time. So you draw the axis. Then here, you name the axis. We have distance, and the distance in meters. Then we have time, right, the SI unit of time, which is second. So for a body that is not moving, it simply means that the distance remains the same. The distance does not change, but time will keep changing. So therefore, we are going to have, let's say the distance initially is at that point, we are going to have a graph, a line that is parallel to the time axis, parallel to the time axis. So that's what we have for a body that is stationary. You can see the distance is not changing. For example, if the distance here was 2 meters, it can move 2 meters, but now it is stationary. But the time is changing. Let's say this is 0, 1, 2, up maybe to 15 seconds. So the time is changing, whereas the distance is not changing. So this is the time, the distance time graph for a stationary body. We can see that it is a horizontal line. Is a horizontal line. That's a distance time graph for a stationary body. For a stationary body, therefore we can say that it is a straight line, a horizontal line. Let's talk of a horizontal line, parallel to the time axis, So you can see that the distance is not changing as the time changes. Then we have number B, for a body moving at a uniform speed. We have a stationary body here, then we have a body moving at a constant or uniform speed. A body moving at a constant or at a uniform speed. So before I explain about this body, you need to understand that whenever we have a graph, any graph of distance against time, or a distance time graph, if we have our distance here on the y-axis, distance in meters, then we have the time here in seconds, and let's say we have a graph, we have a straight line of that sort, you should always note that because we say that the speed is given by the distance covered per unit time, per the time taken. And therefore, from this graph, we can be able to see very well that if we want to calculate the gradient or the slope of this graph, if we want to calculate the slope, let's say we have the point here, we read this point and this other one, let's say here we have 0, let's say here we have T1, then on this other side for distance, let's say we have D1, then here let's say we have T2, and then here we have the distance as D2. So we are going to have at this point here, we have T1, D1, those are the coordinates. Then we have at this point, we have T2, D2. And therefore, if we want to get the slope, which we also call the gradient, we are going to have, we know that the gradient is given by change in y all over change in x. Change in y all over change in x. In our case, our y is change in distance divided by change in time, in the time axis. So we are going to have the change, we have the coordinates, so we have change in distance, so we are going to have D2 minus D1, all over change in time, whereby we have T2 minus T1. And you can see here we'll have, therefore, it's like we're having now, therefore, the distance divided by the time. The distance divided by the time. That is what is giving us the slope. And therefore, you can see the slope is equal to the speed, because this is the distance over the time taken. So we can see that for a distance time graph, the gradient or the slope gives us the speed. The gradient of that graph will give us the speed, because you can see that the gradient is change in the distance divided by the change in time, which is giving us now, this is the distance, D2 minus D1, the distance divided by the time taken from T1 to T2. So we have divided by the time. So the slope is equal to the speed. That is for a distance time graph. So for a body moving at a uniform speed,